as you guys probably know, we've spent the last little over a year trying to build what we think the perfect graphing calculator would be in this day of browsers and everyone having devices. And so we've been working on Desmos, and with your help, we've been making it something that we think is a great way to explore and understand math. But what we decided we really want to focus on going forward is making sure this is really useful inside of classrooms. So making sure that teachers have all of the scaffolding that they need to be able to use this effectively with their students. And this webinar is the first in what we hope is going to be a series of showing people how to use Desmos. So this is, in the first part, this is kind of an experiment, and you guys are helping us with this experiment. So as we do this, please chat us using the text box in the corner if you have questions about this particular webinar, if you want us to go faster or slower, if you can't hear, and then, of course, ideas you have on how we can make what we're showing you today better. So I also want to give a little bit of background on Classroom Concepts. It's born from the same motivation. We really want to give you an easy way to find all of the stuff that we've already seen people doing with the calculator as a way of demonstrating ideas. And so we've seen really great work using Desmos to draw pictures, and also using Desmos to demonstrate concepts. And this is totally focused on the latter. This is taking advantage of sliders, different forms of equations, and some of the coolest features that we have in Desmos, all aggregated into one place where you can start to explore these concepts with your class and with your colleagues. So our first caveat is that this is very much version 1. We're going to keep working on this. We're going to keep iterating. You've already given us some good ideas, and we hope to get some more out of today. So very, very early, and please keep giving us your feedback and know that it's just going to get better with time. So with that, I want to turn over the floor to Luke Walsh, who's going to be taking us through some of the ways he uses Classroom Concepts already, even though it's only a few days old. Luke is an instructor at CVCC College. This is Catawba Valley Community College. Before that, he was a teacher at the high school level as well, and has been an avid Desmos fan for a long time, and actually is now helping us in all sorts of different ways, including on our Twitter feed. So some of you have probably been interacting with him already, and we're very excited to turn the floor over to him to take you through how he's using our version 1 of Classroom Concepts. Luke, you're on.
Thanks, Eli. All right, so here we are in the Explore the Math with Classroom Concepts. And basically on the left-hand side, we have kind of organized some different sections. We have the basics that go from the lines all the way up to calculus. And we kind of just give, right now there's just about 3 or 4 in each of these. So I'd like to maybe just go through a couple of them just to see what they're like. Basically, the concepts are just to give you ideas of maybe some way of just getting started of using Desmos and integrating it into a certain lesson plan. Let's see here. Let's pick one over here in the lines. Let's go with a slope-intercept form. A very common one, the basic linear equation. And here we have a good example of seeing the sliders. We have a slider of M and a slider of B. So here we go. This is a very nice, simple graph, but you can build from this with a lot of different things, right? So maybe in the beginning, you can just kind of see how you have these different sliders to show how the slope actually affects the equation. With each of these sliders, you can also change them. So you can either click on the left bound or the right bound. Right, and then you can just make it be anything that you want. So I could have it go from 10 to negative 12. I mean, negative 10 to 12. Also, if you don't like it to go everything in between there, maybe you'd rather have it go up in maybe 0.5. So now we can kind of see it just a little bit differently. So the sliders can really be used in many different ways. Also, you can also come up to here and just kind of pick a value. Let's say you just want to go 50. And maybe that could be a quicker way to just kind of change some things to go to a higher bound. Excuse me. All right, so with these sliders, though, you can do lots of different things. I'm just going to go back to making this be 10. And maybe you just started doing this, and maybe you want to look at the slope a little bit differently. So if you want to go ahead and just modify this graph, you can start to begin to make it your own. Like, let's say, well, I don't want to really use the slope as just an m value. Maybe we can do, maybe create something like a rise or a run. So to create a new expression, you can either go down here where we have expression, table, or text. Right? So maybe in the very beginning you want to make some labels. So you can either click the text. Right? So here I'll say, let's make the rise or the equation. No, that's not good. Let's go rise of the slope. That seems a little better. And so now you can make any other letter that you want for the slope. You can just call it T. But probably R would be a good one, maybe for rise. But be careful because we have in Desmos, they've already established some certain letters. So R actually means a polar coordinate. So you have to be kind of careful with some things there. But one nice thing is that you can kind of make your labels. So I can do a subscript here. And I can just kind of type in rise. So now you can actually see the whole word rise, but it's just actually a variable. But seeing that might be kind of clear for students. And actually being kind of clear for students, a lot of times in my classroom, this is just up on my projector screen. A lot of students don't have Desmos. So what I'll do is I'll go over here in the right-hand corner. And over here at the little wrench, I'll go ahead and switch it to projector mode for my students. So in projector mode, everything is a little bit thicker. Notice on the left-hand side here that everything's a lot larger. This helps my students in the back row. So going back over here to the rise, so now I can just say, I want this to equal 1. All right, so I now have made a slider value for my rise, and I'll just make a slider value for the run. All right, so now I have a couple sliders, rise and run. So now I can look at the slope, not really in terms of just m, because that's just m over 1 each time, but now I can go back and I can call this rise divided by run. Oops, I have to go underscore. So now I've kind of gotten rid of this m value here, but now I can really ask students some questions. And maybe before I do it, I might just ask them to ask their neighbor, so if I start moving this rise slider, what do you think will happen? And then maybe I'll get some questions. And what do you think if I move the run slider? So maybe you can ask some questions before you actually start moving them. Right? So then you can begin to move the rise and kind of see how that one worked. You can maybe move the run and see if that's what they thought would kind of happen. Maybe they think it's both the same. You could ask them questions about, well, how is moving the run slider different from moving the rise slider? And right now you might be saying, well, I can't really see those. If you're on the left-hand side here, you can also drag sliders around, or not just sliders, you can drag any expression. So now it's more up there at the top. And it looks like I'm not really using this M slider anymore. So I can go over here to the edit screen. And we have these features right now. Duplicate, X. So I'll just go ahead and just remove this. There we go. And maybe I want to change the color. Change it to blue. There we go. So now I've kind of started with that MX plus B. And now I can ask some students about rise versus run. And then maybe you could say, well, what about if we had the same equation, but we kind of just switched them? We had the run on top and the rise. Does that really matter? So maybe it's pretty much the same thing. So I can go here and duplicate, just maybe a little bit quicker than typing everything. And I can just go back and put run there and rise. Oops, I have rise. There we go. And right now they're both blue. It might be hard to pick
Luke, quick question for people who haven't seen subscripts before. Can you describe exactly how you make a subscript on a variable?
Oh yes, awesome. Let me go back down here. So to make a subscript is doing a a shift and a dash. So that's over there by the 0. Let's see. So if I want to do W, and I can go shift and then subscript. So maybe like a 1. And if you don't like the subscripts, maybe you could just do different letters or work just fine. You could just do maybe a capital B and then a capital A. But I like to use the subscript sometimes because it actually sees the word there. But whatever you're comfortable with. So the subscript is right there, shift and the dash right up there at the top right-hand corner. Let's see, so we're at this one, so I'm going to go ahead and make this be a red one. All right, so now I got 2, and so now you might ask students, what happens now if I start moving the rise? Or what happens now if I start using the run? All right, so we start to see this type of thing. You might say, well, what's the largest that they could ever be apart? Or what's this largest angle? Could there ever be a 90-degree angle? Oh, one of them disappears. You can talk about why is the red one disappearing versus how could I make the blue one disappear? Right. So there's an example, and then maybe just to finish it off, you could maybe say, well, let's just throw a little negative there. Oh, that's interesting. And then you can start moving these around. You're like, huh, those really don't seem to be changing too much. Looks like those are special type of lines. So we began with a simple concept of just doing y equals mx plus b, but it can lead to perpendicular, it can lead to parallel. One other thing you might want to see is how you could do some restrictions. Maybe you can show your students how to do a domain restriction. So with this line, you could say, I only want to look at this line between -5 and 5. So notice that when I do less than or equal to, the equal sign just goes right underneath it. Let's see. There we go. I had to put the correct parentheses in there. Let's see. Did that work right? Yeah. So now as we can see, if I kind of just restricted the domain of this equation. Now there's a couple ways to do that. I have written the domain restriction after the equation. Another way to do this is to actually do it inside of your equation. So those are 2 different ways that you could actually restrict your domain, either inside or after, whatever is your preference. And so now you can start moving these around, and you see there's a lot of different changes that we didn't really see before that we do now see with these restrictions. You see how they're really increasing in length. All right, let's see. Would there be any other features that we could show there? Oh, I mean, could there be lots of features? But I think we're starting to get the idea of how you can just take a simple concept and just really add your creativity, or just ask some students of what you could do next. All righty, so I'm going to go back to, so that's our first example of just looking at some linear equations. Let's go back to another one. Let's see, so that was something there in lines. And then maybe we should go over to our next one here, the parabolas. You could start looking at the factored form, vertex form, or a factored form. Let's take a look at this vertex form. Let's go ahead and modify this graph. But once again, we see these classic sliders. And maybe you could just ask students again, what will the A value be doing to the equation? What will the H be doing? So it's really dynamic. It's amazing seeing the students' reactions, just moving a very simple slider, how quickly they connect with it. Notice that there's a point down here, H comma K, And you could also plot other points right next to it as well. You could go up to here. Instead of calling this y, you could just label it as a function. You could do f of x. And so now if you want to make another coordinate point on here, let's just say, let's pick the point 1, comma, f of 1. Oops, that's 0. Let's do something a little bit outside. There we go. So notice that they are both purple because they're both on the same line. If you wanted a different color, you just switch to the next line here. But now notice that those points will always stay. But what's kind of interesting is that it looks like that point is moving around because it's always at the 5 value. You can look at the 5 value maybe just by doing like a vertical line. You could do x equals 5. And just kind of show how it's always, that point is always staying on there. The only thing that's really changing are the outputs, right? Because it's f of 5 right there. And over here on the left-hand side, you can also hide the graph if I don't want to see it right now. There we go. I can just go ahead and hide it. Now notice earlier I labeled this as f of x. So that allows me to call back the function. I can maybe make another function, g of x. And I could say, well, how about I just make something be f of x minus 2. So now you can talk about what does this really mean, x minus 2, and you can bring up this idea about transformation. But you know, just calling that 2 is no fun. Well, that sort of is fun, but we always love to use sliders. Oop, I'm already using the slider value a. I'm going to use a capital A. So it doesn't really see that, so I have to tell Desmos to add the slider value, a equals 1. There it pops up. And now I can just start moving this one. Now I can go back to this other one and see how they both move together. Because if I change one, it changes the other. But this is the one that's actually moving it left and right. And you could add other things. You could be doing like a plus a b value. So you can go down and add a b slider. So then you can just have a lesson about the transformations, adding a b value and a value. And then maybe one more thing here. If you want to add another coordinate point, let's see. So adding another coordinate point. What coordinate point could we add here? Let's see. I'm going to go down here and add a slider value of maybe, we'll call this value of a c value of 1. So let's see. I'm going to make this be c comma f. Oops, f of c. Let's see. So where's my little green point? There's my little green point. Now you might ask your students, where would this green point be? Over here on this orange line. Right? Now remember, the orange line is this G transformation. So maybe you could talk to your students about that and help them kind of figure that out. So here you have the transformation of x minus a. Let's see if I do this correctly. So c, this should be c plus a, value of f of c plus c. Let's see, I'm going to make that not be purple, I'll make it be red. Let's see. For some reason, does that look right to me? For some reason, that looks a little strange to me. I'll let you figure that out. For some reason, that point looks a little bit. Oh, well, they're both on the line. I guess you would have your students figure out. Oh, yeah, because the transformation is going down. Okay, good. So those are right. But there you go. So that's kind of interesting way to look at the transformations of having the coordinate points and then also transformation with the graphs there. And maybe one last feature you could kind of show here is going back up here to the edit. Here we have this convert to a table. So you can convert any function or equation to a table. And you can see a list of values there. And you could just add a value. Once on the left-hand side here, once there's more than 3 values, the Desmos will understand the pattern that you're trying to do. So I can go ahead and just start adding a whole bunch of points if I wanted to. Over here in this top part right here are your options. So you can show the curve. You can show the points if I just want to hide those. You can change different colors. Insert left and right. Oops, I guess everything's orange now. It kind of looks the same. So again, we started with a very simple graph of just a parabola of a x minus h squared in plus k in a vertex form. We saw how we could make a table. We added some of our own sliders. We showed how we can make some transformations. Look at how one point moves to another point. So right there, that's already like a couple days of lessons. And so there in these concepts over here, they do look very short, but they're very short and sweet. They're just really allowing you to kind of explore and just add your own special touch to each one. So you have the conic sections. This one's pretty cool. I really like this one. It has the 3 different points, have students pick a circle. You got your transformations, which we just got doing, translating a parabola, which you can do inverses, exponentials, some modeling, and some really interesting calculus graphs. So there we go. There's a quick introduction to some possibilities of how you could maybe begin using the Desmos concepts in your classroom.
Luke, I was wondering if you could show us, once you've modified one of these graphs, if you wanted to use it in your class, can you show us how you save your work?
Okay, sure. Perfect. All right, so now you think you got some awesome work that you want to share. You want to bring it up for later. So over here in the right-hand corner, you'll have to log into your account. All right, so I'll just log into my account. So now once you're logged into your account, you have your saving options are over here on the top. This is already kind of labeled for me, but I can go over here to this ancient, awesome save disk feature that everyone uses. Line and slope intercept form. You could just call it lesson 2.1 or you know, whatever it's going to help you remember it. And you could call it awesome graph 318. Boom. You save your graph. Notice there was a quick little green over there. All right, so now you just come back into Desmos. Over here on the left-hand side, you've got your saved graphs. So you'll have to scroll through, but this one's just my very recent one. So notice within here you have these little trash cans that can help you delete one. Right? Or you can just bring one up by just clicking on it. All right, and there you go. You have it right back, saved, ready for you. If you're using your Google account, you can actually save that to your Google Drive. We also have these features where you can print out this graph. Then a print screen would come up for you. Right now, we do not have where you actually get the equations printed out. A lot of people have asked for that, and we're kind of working on that. But you also have many different options to share. You could tweet out your graph, maybe if you have a Twitter account for your classroom, or if you want to share it with other teachers, you could Just click on that Twitter button and it would bring up your Twitter account. You could share it with people. It's pretty tempting to tweet that out, but I won't. Let's see, going back to my graph, another one that you could do is maybe save it as an image. So maybe if you wanted to use this for a test, you could have students say, what is the slope of this equation? If you're using Word, you could just do like a right-hand click. You could just copy the image and then paste it into your Word document. Or up at the top here, you could have this where you could actually save the image to import it into your blog or your web page. Or you can just actually just right-hand click and just save your link to your desktop. Save link file to the desktop. Right, so then you could bring it up for later, like in class. Like if you don't want them to see your equations, you could bring it up like that. You could also bring up maybe in Word if you want to insert that picture. And then also we have the embed. I've used this a couple of times with like a discussion board. If you have discussion boards, that brings up a nice little picture that's kind of nice. I really haven't used the BB code. The email feature, if you just want to send this to your mom or something. Or, I don't know why I said your mom. If you just want to send it to your student or just anybody else, here's this message, happy Math Day. You love it. All right, so then you can go ahead and send out that message. So there's plenty of ways to actually share this. I think this is one of the most powerful things about Desmos, of how quickly you can do something and then share it. A lot of times, some students will have some questions. I could start a new one and answering their questions. So I could say, here is a question about number 2 on page 34. Right? And I could talk about, well, here's this equation, and basically I could go through the questions that they might have emailed me, or maybe questions they had in class, and then I can just go ahead and save the graph. And then once I save the graph, I could just email them that link. Okay, so going back to there, so that's a little bit of how to, once you have your expressions, of how to share it, save it, and love it, I guess.
Great, Luke. That was amazing. Any questions for Luke or for us about how Luke uses this in the classroom, or our plans for it going forward? And you can chat them over in the window, or you can always tweet at us at Desmos or send us emails at calculator@desmos.com. But thank you so much for taking us through all of this. And as we said, this is just step 1. We're hoping to do many more of these webinars, and we're hoping to keep building out the set of resources that are available to help you discover these concepts in your class. So thanks again for being part of our first one, and thanks so much, Luke. And we'll see you next time.